Hi dear students, welcome all of you to Unique World Education YouTube channel. This is Fazlur Rahman, Chemistry Faculty of Unique World Education. Hope all of you are doing great. So today we are going to continue the third part of sample question paper discussion of grade 10. The sample question paper which is released in the official website of CBSE for 2024-25. Okay. So I hope all of you watched the previous videos very clearly, and I hope all of you are very clear about the questions that we discussed in the previous sessions. So today we are going to continue with section section D and section E part. Okay, long questions. So we can directly get into the questions. Coming to this particular question, so I will read the question very carefully. First you can listen. Kirti thinks that substitution reaction occurs in a saturated hydrocarbon. On the contrary, Krishi thinks it occurs in unsaturated hydrocarbons. Justify with valid reasoning whose thinking is correct. So, I hope all of you remember we have studied substitution reaction and addition reactions, oxidation reaction, combustion reactions and all in carbon compound chapter. Okay. Can you please tell me, substitution reactions are happening in saturated or unsaturated hydrocarbons? Which is the answer? See, substitution means what? See, I will give you one example here, listen. Methane. Methane plus chlorine. Methane plus chlorine will give you what? Chloromethane. CH3Cl plus HCl. Okay. So what's happening here exactly? One of the hydrogen from methane is replaced or substituted by chlorine. Okay, that's how you are getting chloromethane. So this is substitution reaction and which is happening in saturated hydrocarbon. Okay, saturated. So I can say Kirti's thought was correct. Okay. What is happening to unsaturated hydrocarbon? Unsaturated hydrocarbon, for example, CH2 double bond CH2. What is this? Ethene. Okay. Plus H2. Plus H2, you will get what? CH3. CH3. What is this? This is ethane. So, unsaturated hydrocarbons undergo, this is which type of reaction? Addition reaction. Okay. So the answer is Kirti's thought was correct because saturated hydrocarbons undergo substitution reaction. Okay. I hope that's clear. Coming to the next one. Yeah. Methane and propane and their isomers are used as fuels. Methane and propane. Methane and propane and their isomers are used as fuel. What is a fuel exactly? A fuel means which on combustion or which on burning process, especially complete burning, should liberate large amount of heat. Okay. So methane, propane and their isomers on burning means plus O2, complete combustion, they are releasing large amount of heat. They are releasing large amount of heat plus carbon dioxide. Okay, carbon dioxide plus this large amount of heat will be produced. That's why they are used as what? They are used as fuels. Okay, I hope it's correct. I mean, I hope all of you are clear. Okay. So methane, propane and their isomers are releasing large amount of heat on complete combustion. So they undergo complete burning or complete combustion to release large amount of heat plus carbon dioxide plus water. Okay, plus water vapors. And draw the electron dot structure of the immediate lower homologue of propane. Which is the immediate lower homologue of propane? First you have to know about homologous series. The homologous series of alkanes are like starting from methane, ethane, propane, then butane, pentane, like that. Okay. So immediate lower homologue of propane is, that is ethane. Okay. So you have to draw the electron dot structure of ethane. Ethane, all of you know, that is this one. Ethane is just this one, C2H6. Okay. Yeah. So now we can draw electron dot structure of ethane. Listen, I hope all of you know this. Okay. Electron dot structure means what? Electron dot structure means you have to represent the valence electrons. Valence electrons as dots. Okay. This structure is also called Lewis dot structure. Okay. So two carbon atoms are there. Each carbon will have 4 valence electrons. Each carbon will have 4 valence electrons. 4 valence electrons. Okay. And each of these 4 valence electrons are shared with 4 hydrogen atoms. I mean, for each carbon, 3 hydrogen atom. Okay. One hydrogen, another hydrogen, next hydrogen, next one, and next one. Okay. So this is the electron dot structure for ethane, and if you want, you can draw circles as well. Okay. So this is the exact electron dot structure. So if all are single bonds, if it is alkanes, sharing will be by 2 electrons. Okay. One pair of electron will be shared between 2 atoms. You can see one pair of electron is shared, which leads to formation of a single covalent bond. Okay. If there is a double bond, you have to share 4 electrons. Okay, 2 pairs of electron, and for triple bond you have to share how many pairs? 3 pairs of electron. Okay. I hope all of you got it. Moving to the next one. A mixture of oxygen and ethane is burned for welding. Okay. Ethane. Mixture of ethane. Ethane plus O2. What is ethane? Ethane means C2H2. Okay. Ethane plus O2 is used for welding. Can you predict why a mixture of ethane and air is not used? Okay. Ethane plus air. Ethane plus oxygen is used for welding because it will undergo complete combustion. It will undergo complete combustion to produce a clear blue colored flame. Okay, clear blue colored flame which undergo complete combustion. But if you are using a mixture of ethane and air, which will not lead to a complete combustion process. Okay, not complete combustion, not completely combusted, completely burned. Okay, and which will lead to sooty flame. Okay, which will lead to sooty flame. That's the reason. Clear? Yeah. So we finished that particular question, A part, and we can check the OR question. A and B are sodium salts of long chain carboxylic acids and long chain sulfonic acids respectively. So A is sodium salt of long chain carboxylic acid. Okay, I will represent that as RCOONA, sodium salt of long chain carboxylic acid, and B is sodium salt of sulfonic acid. Sodium salt of sulfonic acid. Sulfonic acid is SO3H. You will study in higher classes. Okay, so what is this exactly? Sodium salt of long chain carboxylic acid, that is what? That is soap. Okay, and sodium salt of sulfonic acid, what is that? That is detergent. That is detergent. Okay. So the question is, which one of A or B will you prefer as a cleansing agent while using underground water? You know, underground water is hard water. Underground water will be hard water. So we studied in this particular topic, soap is not effective in hard water, but detergents are highly effective in hard water. Okay, so which is the answer? B. Okay, B we can prefer for using with which one? This hard water. Okay, I hope all of you know the reason, because this soap molecules will form precipitate, insoluble precipitate with calcium and magnesium ions present in hard water. That's why. Okay, so here the answer is B, and that is the reason. Okay, because B is detergents which are highly effective in hard water. Okay, because they are not forming any insoluble precipitates with calcium and magnesium ions. Okay, yes. Next, elaborate on process of cleansing action of soap, and illustrate mycelium with help of labeled diagram. Okay, as I already told you, soap is long sodium or potassium salts of long chain fatty acid or long chain carboxylic acids. So RCOONA if it is sodium salt, RCOOK if it is potassium salt. Okay, what is this R? This R is alkyl group, hydrocarbon chain. Okay, a soap molecule you can consider a soap molecule like this. That means which will have a head portion and a tail portion. Head portion and a tail portion. So listen carefully, it's very important topic. So this head portion and tail portion which has two important properties. Okay, this tail portion is hydrophobic in nature. Hydrophobic. So these words are very important. Hydrophobic means water hating. That means this end will not dissolve in water. So you can say insoluble in water. But this end will be soluble in lipid solvents. Okay, organic solvents. So you can say that is lipophilic. Okay, lipophilic in nature. One more term you have to remember regarding this particular end. So this will be non-polar end. Non-polar means no charge. Okay, yes. And this head portion, so just opposite. Head portion will be polar. So polar means what? Having charged. Okay, so that will be hydrophilic in nature. Hydrophilic means water loving means water dissolving. So that end will be soluble in water. Okay, soluble in water, and that will be soluble in water. Water soluble, hydrophilic or polar. Okay, polar. So if you take this particular example, I'll show you RCOONA. RCOONA can be splitted like COO minus and this Na plus. Okay, so you can see this end portion is charged. Okay, so that is polar, which will be hydrophilic in nature. and this hydrocarbon chain will be hydrophobic in nature, which will be lipophilic. Okay, lipophilic. Okay. So this is the introduction, or these are the terms you need to remember, or you need to include, you must include in your answer while writing answer for this type of question. Okay. That means polar and non-polar, hydrophilic and hydrophobic, and lipophilic and lipophobic. Okay. Yes, good. Now I'll tell you how this cleaning action is done by soap molecules. So first of all, the dirt particle, dirt molecule in our cloth is considered as a greasy texture or appearance, greasy or oily. So the dirt particle is considered as oily means what? Oily means lipid. Okay, so lipid, oily means lipid. Okay, so our soap molecules, as I told you, it has two parts. One is hydrophilic and the other one is hydrophobic. So hydrophobic means lipophilic. Hydrophobic means lipophilic. So all the lipophilic ends of soap molecules will be directing towards this dirt particle, because dirt particle is what? Lipid. Dirt particle is lipid or hydrophobic. So the soap molecule will arrange in such a way that it will try to this dirt particle pull out from the cloth, by arranging in this way. Which way? That means all the hydrophobic end is directing towards the dirt particle, and all the hydrophilic end, that means polar end, will be extending outwards into the water molecules. Okay, so these are the polar ends, polar hydrophilic ends, which is water soluble. So this particular end will dissolve in water, okay, and this particular end will dissolve in that particular, which one? Dirt. Okay, so by arranging like this, a soap molecule is helping to take or pull out the dirt from your cloth during washing process. Okay, and this structure, spherical structure formed, that is called mycelium. Okay, mycelium, and these are soap molecules. Okay, so this is the hydrophobic dirt molecule, hydrophobic dirt particle. Okay, so this is the polar end or hydrophilic end of soap molecule. Okay, so I hope all of you got it. Clear? Yeah. So that's about the cleansing action of soap. Next is write the chemical equation of the preparation of soap from an ester CH3COOCH3. What is the name of this process? Preparation of soap. What is the name of that process? Saponification. Okay. Name of the process is saponification. Name of the process is saponification. Preparation of soap. Okay. Ester is treated with what? Ester is treated with, write the chemical equation of the preparation of soap from an ester. Ester you have to treat with sodium hydroxide, a strong base. Okay. So the ester is CH3 CH3 COO, C double bond O, that is the ester group. Okay, then one more CH3, one more CH3 plus NaOH, plus NaOH, NaOH, sodium hydroxide. So what you will get? You will get the soap molecule. Soap molecules, that means CH3 COO, CH3 COONA, CH3 COONA, plus then what is left? This Na and this much part. This much part is released as CH3 COONA, and what is left? CH3OH. Okay, CH3OH, CH3OH. So this molecule is actually soap molecule. This molecule is actually soap molecule. Okay, and you will get the corresponding alcohol also. I mean, from this alcohol and carboxylic acid you are getting this particular ester. So that alcohols will be generated back, released back. Clear? This reaction is called a saponification reaction. This reaction is called a saponification. Saponification means preparation of soap. Preparation of soap. Okay. So I hope this clear. We can move to the next question. Okay. Yes. Yeah. So it's again a very important question. We can check. Different reactions are given, you have to fill. Coming to the first one, A plus H2O, A plus H2O undergo electrolysis to give X plus Y plus Z. Okay, A plus H2O, A plus H2O, that A, can you tell me which is this reaction? Electrolysis. Electrolysis, and you are getting caustic soda. Okay, so I will write the reaction first. A plus H2O. A plus H2O gives X plus Y plus Z. Okay, Y and Z are gases, that is already given, that is already represented in the reaction. Okay, what is caustic soda? What is caustic soda? Caustic soda is NaOH. NaOH, sodium hydroxide. Okay, so X is sodium hydroxide. X is sodium hydroxide. So this is chloralkali process. Chloralkali process, which is done by electrolysis of brine solution. I hope all of you remember. Okay, so what is A? What is A? A is NaCl. A is NaCl. So NaCl plus H2O gives NaOH plus. At anode. At anode, what will be there at anode? Chlorine. Chlorine gas, Cl2. And at cathode hydrogen, H2 gas. So this is the first equation. I hope it's clear. So A is NaCl, X is NaOH, Y is Cl2, Z is H2. Okay, that is the first one. That is the first one. Coming to the second one, A. What is A? NaCl. Okay, A is NaCl. So molten NaCl, molten NaCl, molten NaCl undergo electrolysis. Undergo electrolysis. So M at cathode. What are the products of electrolysis of molten NaCl? That is for preparing what? For refining, for extraction and refining. Okay, purification of metal, highly reactive metals. So you will get that pure metal at cathode. Okay, so at cathode you will get what? Sodium. At cathode you will get sodium plus chlorine. Okay, chlorine at anode. Okay, So M is Na. M is Na and Z already we identified, sorry, Y we already we identified, that is Cl2. Okay, that's it. Then coming to third one, coming to third one, coming to third one, yeah, third one, M plus CH3COOH. What is M? M is Na. So Na plus CH3COOH. Na plus CH3COOH. Reaction between acetic acid and sodium. Acetic acid and sodium. What will happen? M plus CH3COOH, P plus H2. P plus H2. P plus H2. So what will be the reaction? What will be P? What will be P? What will happen if acetic acid reacts with the sodium metal? So that will be CH3COONA plus H2. CH3COONA plus H2. So P is CH3COONA, sodium acetate plus H2 hydrogen gas. H2 hydrogen gas. And fourth one, CH3COOH, again acetic acid, CH3COOH plus Q, in the presence of concentrated sulfuric acid, you are getting what? R. What is that reaction? That is esterification reaction. CH3COOH plus Q. CH3COOH plus Q. So what is that? Alcohol. Okay, that is C2H5OH. C2H5OH. In the presence of concentrated sulfuric acid, you will get one particular ester, which is CH3COOC2H5. Okay, that is the ester. That is the ester. And one more reaction, 5, that is this particular ester. That particular ester, CH3COOC2H5, CH3COOC2H5 plus X. What is X? Caustic soda, NaOH, plus NaOH, P plus Q. This is saponification. Saponification, you will get what? Soap molecule plus that alcohol back. Okay, so CH3COONA plus C2H5OH. Okay, so it's a very important question. You may get confused because lot of reactions are connected here. Okay, so the question, derive the names of A. So A we have found out, that is NaCl. Okay, and Y Cl2, and Z, that is H2. Then M is sodium, and then which one? P is sodium acetate. P is sodium acetate, and R is this ester. What is the name of this ester? What is the name of this ester? This is ethyl ethanoate. Ethyl ethanoate. Okay. Yeah. So I hope everyone is very clear about the question what we discussed today. So we will discuss the next question and remaining part of this paper next class, next video. I hope all of you got the concepts very clear, very crystal clear. Okay. If you have any doubts, you can put in comment box. Okay. So we can wind up now. Thank you all. Bye. Take care. Just wait.